Guys, welcome back to another tutorial. For this one, I'm going to be teaching you WebSockets, and I'm going to try to explain it in such a way that you can understand it if you have never come across it. If you're planning to focus more as a backend developer, it is important for you to know what WebSocket is. It's also important for you to use it. So without wasting your time, I'm going to be breaking down how WebSocket works. And at the end of the video, I believe every information I'm going to share here is going to help you to understand WebSocket in a different dimension, and you can start walking around with it, and hopefully a whole lot will make sense. Now, let me explain WebSocket. To understand WebSockets, we will dive into a whole lot of things. And I'm going to tell you guys a story, a short one, to explain this in a different way. The reason why I'm telling this story is because I have understood that one of the best ways for human beings to understand things is by telling stories. So I'm going to try to tell a scenario where we can use a WebSocket to solve a problem. Here is the story. Peter and Stacy are best friends. Peter owns a small but popular cafe in town, and Stacy loves hanging out there. One day, Peter notices that customers are unhappy because their orders take too long to be updated on the display screen. This is a problem. The cafe uses a traditional request response system. Every time a customer places an order, the system saves it in a database. However, the display screen in the kitchen only captures when someone refreshes the page. Because of this, it is causing delays, making chefs work with outdated orders. For every problem, there is a solution: WebSocket. Stacy suggests that a real-time system where the kitchen displays orders automatically the moment a new order is placed is created. Stacy goes ahead and suggests that instead of refreshing the page or manually sending new requests every few seconds, the system should establish a direct, always-on connection between the customer's device, that is the client, and the cafe's server. That way there will be a persistent communication. The moment Peter enters an order, it appears instantly on the kitchen's display. Now, the key to making this happen is WebSocket, because WebSocket makes it possible to have a persistent communication between the client and the server without having to keep on sending requests every time we want to establish a connection between both ways. I hope this story is putting something in your head. Like I mentioned, WebSocket creates a persistent communication between the server and the client. To further explain what WebSocket is, I'm going to explain it in three ways, comparing both HTTP, then finally comparing WebSocket. The part one is, WebSocket is like a phone call between the client and the server. Let's say a phone call between two people, whereby when you're calling Mr. A and you're talking to Mr. B, you're instantly hearing what Mr. A is saying. It's not taking you minutes or hours for you to wait before you hear what Mr. A is saying to you. That is how WebSocket works. It is a situation whereby both can talk to each other without hanging up or without waiting so long to establish a connection. Whereas for HTTP communication, you have a situation whereby a client sends a message and the server responds. It is like sending letters through the post office. Remember, it's slow but one way. That is one of the problems of HTTP. With WebSocket communication, immediately a client and a server establish a connection, like a phone call, where both can send and receive message at any time. The connection continues without having to be sending a request to establish a connection anytime you want to make a phone call. Or let me say, anytime you want to say a word, you don't need to be making another request. That is what WebSocket does for. Now, to understand WebSocket, let me bring what we call IPS. The full meaning of IPS is Internet Protocol Suite. And to explain Internet Protocol Suite, I'm going to explain it capturing the three layers. 1, application layer. 2, internet layer. And 3, transport layer. Let's start with the application layer. This comprises of HTTP, WebSockets, SSL, IMAP. I will come back to this because we are going to be focusing on this since we are talking about WebSockets. The next one I'm going to explain to you guys is the internet layer. Let's say you have worked in networking and you deal with IPv4 and IPv6. Then you might really understand more what I'm saying here in the internet layer. But I'm not going to dive more in the networking aspect of this. But if you want to understand more of the networking, you can always Google and you have more information. The internet layer comprises of the IPv4 and the IPv6. The IPv4 and the IPv6 are the addresses which packages are sent to. For example, IP address. The next one is the transport layer, This one is for defining the way packages are transferred around the web. It comprises of the TCP and the UDP. The TCP guarantees that any package you send over the web reaches its destination in the same order it was sent. Take note, let's say you have a data you're sending through TCP. What TCP does is that when you send that data, it ensures that no element of that data is lost. Everything you send, it is the way the client is going to receive. Whereas for the UDP, it is a bit more careless. That means it doesn't really care or guarantees that whatever you sent over, you're going to receive that same amount of data without it being compromised. Now for the UDP, it is used mostly for streaming videos where we don't care if we lose some of the packages on the way. With all this explanation, we can then come back to the application layer, because this is where we are going to be working more as a developer. When you're developing applications, you will come across HTTP, and the application layer is where HTTP falls under. Other things that fall under application layer, I don't know if I mentioned it when I started this explanation, is the SSL, the WebSocket itself. To explain more on this application layer, since it is our focus for WebSocket and the like, I'm going to be talking more on the HTTP request and response, where a client sends a request, server processes it, and responds with a response. This is what happens through Hypertext Transfer Protocol. It has its own capabilities. One, it is stateless. After the initial request is done, the server-client communication is lost, which was actually one of the things that made developers or engineers worry much about HTTP, because it is not real time. Whenever you send a request, aside from not being real time, once that request is received and a response is returned back to the client, the communication is lost. That is one of the capabilities of HTTP. It can work depending on the kind of application you're building. This can actually work fine. In fact, most applications that run on the web is stateless, and what it offers can suffice. But when you're building more complex things that has to do with like a chat system, that becomes a problem, because you'll be needing a real-time scenario. So HTTP will not be enough. Another capability of HTTP is that clients specify actions. You have to specify actions like the get, the post, the put, and the delete. Another capability is that when data are sent, they are sent with headers. Headers with the request and the response. What led to WebSocket? In 2008, that was the year WebSocket was founded. Now in 2005, there was a need for more than just sending requests and response that are lost once the request is completed. This was what led to the AJAX request. For the AJAX request, I mean the asynchronous JavaScript and XML. I believe if you have been working on the web, you must have worked with AJAX request. It had its own capability. With asynchronous request, we could send data to server without refreshing, which was fine. Clients could request to the server responds, then client continues to make the request without hindrance or refreshing. This was what AJAX could do for us. But what happens when you want to do more than that? A situation whereby you have a chat system where you want real-time communication. That becomes a problem. AJAX could not do that. That was what led in 2008. There was a need to have a real-time scenario in the picture. WebSockets were invented in 2008 by Michael Carter and Lynn Hickson as part of an effort to improve real-time communication on the web. The protocol was later standardized by the IETF, that is the Internet Engineering Task Force, in 2011 as ROFC 6455. And it became part of the HTML5 specification by the W3C. And since then, WebSocket has been in play. It has been used to build so many real-time applications that you see on the web today. It has its own advantages. It also has its own disadvantages. It is not built to replace HTTP, but rather, it is built as an upgrade of HTTP. With WebSocket, we can be able to define duplex bidirectional communication. That is real-time communication. WebSocket is built to solve the problem inherently with HTTP. That means it uses the same TCP connection over the web. So instead of having a situation, let me put something here. Let me show you guys what I mean. Instead of the normal HTTP, right? Whenever we want to make requests on the web, whereby we do this. Normally we use HTTP. If it is secure, then we'll have HTTPS. Then we do : / let's say YouTube or UTIN or whatever. This is the way we make requests. So if we want to make requests to YouTube, we'll have to use HTTP. to make that request. But in a situation whereby we are working with WebSocket, we have to use WS, right? Colon / then the endpoint. So let's say we have api.endpoint.com. This is how we can make the request locally when we are developing. But if we are handling like a development that is on production level, we have to use YSS then colon / API, the same endpoint. Now this is how we make requests on the web. So it's an upgrade of HTTP, and it makes use of the TCP to be able to make connection on the web. Also, it is actually very easy to implement once you establish a connection and you make requests. So let's say I make a request over to the web, right? Once I establish this connection to the web here, I'm the actor and I establish a connection to the web. I can go ahead and start sending whatever I want to say hi. Once this guy receives it, he sends it back to the server. The server will return a response and the connection will remain open. Once I send my hi, the server receives, it sends another hi to me or whatever else, and I can go ahead and say, how are you doing? And the server will also go ahead, look at whatever I send. Once it has seen whatever I send, it will go ahead and send the connection back to me. And the whole connection will remain open. There's no need for it not to be open. Like in a scenario whereby we have a HTTP request, it does not stay open. Once this request has been sent, you have to send another header to it for it to remain open. But in a situation whereby we are dealing with WebSockets, the connection remains open. It has its own advantages. One of them is that it only sends the header once. I have already said it is very easy to implement, and it also works well with existing technology. It works well with old technologies, and you can use it different use cases to implement whatever you want to do. Now, I'm going to also reiterate what I said earlier. WebSocket is not built for it to be a replacement for HTTP, but rather it is an upgrade of HTTP. HTTP provides automatic caching. Some of the issues with WebSocket is that sometimes we have a situation whereby it often needs special configuration for load balancing. Sometimes it cannot communicate with REST. You have to also do some special configuration to be able to achieve that. Now, when you're using it to build full complex connection, it is useful for when you're building web-based games or chatting applications that require real-time communication, or anything which needs like a low latency real-time communication. With this explanation, I believe I have done justice to breaking down some of the things that you need to be aware about WebSocket. Let me show you how to use WebSocket in Python. I'm going to be using Django as the framework to implement this thing. Now let's go to the IDE and start building. So guys, welcome back. So this is my folder here, and I'm using Visual Studio Code. And without wasting time, we are going to set up this project. Before we continue, let me quickly explain some of the things you will need for this to work. For you to be able to have this particular connection possible, you need to have a Linux environment because we'll be using a Redis server. And also, I have a live tutorial I built with WebSockets, a chat system. I use React as the front end and Django as the back end. After watching this video, now that you have an understanding of how WebSocket, I will advise you to go back to that video. If you haven't watched it, go and watch it. Look at how I managed to implement a real-time chat system with it and play around with it. I believe it will help you to understand more. I'm going to add the link of that video, the description, so you guys can look at it. So like I said, you need a Linux server. For me, I'm using Ubuntu because I'm using a Windows system. Ubuntu is my server for the Linux system that I'm using to set up because of the Redis server that we are going to be using to run our server for the WebSocket. It's not going to work with a normal server, so we need the help of Redis server to be able to run our WebSocket connection. That's why we are going to be using a Linux system to be able to handle that for us. So if you don't have your system set up to be able to run a Linux server on it, quickly go and watch a video on that. Set up your system. You can use Ubuntu because what I'm using on my system is Ubuntu. Or maybe subsequent videos, I can even make a video on how to set up your system to run Linux on a Windows system because what I'm using is a Windows system to set this up. Another thing is you just need to know how to write Django or Python, which I believe for you to be watching, you must have become good with either Python or you use Django as the framework. Another thing is in the project we will be installing some libraries. One of them is the Django channels. Then we'll install Django itself. It's just a very simple setup to show you guys how it's done. Then we'll need Daphne. Daphne is the server for running our application locally, so we can see if our Redis server is establishing a connection. Daphne is going to help us to run our Redis server locally, and once we establish a connection with the Redis server, we can then test run our application based on the code we have written to see if we have a WebSocket connection established. Let me quickly start setting this up. The first thing I'm going to do is let's set up a virtual environment. So I'm going to do Python mvmv, let's call it env, right? Okay, so we can go ahead and install the dependencies we need. First we'll install Django. Then if we come back here in my GitHub, we have all this information for the real-time chat system built with Django and React. We have the channels Redis. This is how to install it. Then the next one is the Daphne. These are the three things we need, so go ahead and install them. Okay, so let's zoom this a little so you guys can see better. Then clear this out, can save this our to do, close. Now we can do Django admin start project. We'll call it backend. Go ahead and cd into the backend, and we'll do Django admin again, then start. I will call the app the socket. Now we can go ahead and clear, open up our application here, and inside our root folder, let me close the terminal for now. Let me show you guys some things. There are some other things I need to show you guys. So I already have a Linux server, like I said, so I'm going to open up another terminal. So because I have a Linux server, to activate my Linux server, I'm using Ubuntu, I will use WS. You can see this has changed to root HP Libook 840G blah blah blah, then it's showing MNT, meaning I'm now in a Linux server. So if you have your Linux server installed and you're using Ubuntu, once you run WSL, you'll be able to have this. Let's say you want to install the Redis server, right? The way you install a Redis server in Ubuntu is sudo install redis dash. So if I run this now, it's gonna upgrade, but there's no upgrade because I have already upgraded mine. So you see, it said reading list packages done, building dependency done, reading blah blah blah. Redis server is already the newest version, so there's nothing to upgrade. But if you don't have yours, it will go ahead and install. So to make sure that this installation has worked, once you have finished installing, to check if you now have this Redis server, you do sudo service redis dash server. If you do start, it will say starting Redis server. That means your Redis server has started. But if you're not still satisfied, let me clear this so you guys can. If you're not still satisfied, you can run redis CLI and ping. It will return pong to show that your server is running. So this server is running, so we are not going to come back to this. We can now go ahead and start building our project. Once we are done, we are going to establish a connection to this server that is running from our application. Then we will test run our WebSocket to see if it's working with this other server that is running our backend app. Inside our project in the settings.py, let's register our app. The app, we called it sockets. The next thing we have to register is the channels. Okay, so I'm going to add channels right now. Below here, I like to add it below the YSGI. I have to add the ASGI application. The ASGI means Asynchronous Server Gateway Interface, and it is the successor for this YSGI that we have here, which stands for Web Server Gateway Interface. Now, for the ASGI, it helps us to handle asynchronous communication, including the WebSockets, HTTP, and background tasks in Python web application. With this ASGI, we'll be able to have support for async operations, making it ideal for real-time communication. So if you're building for a real-time app, ASGI is what supports asynchronous operations for you. It also helps us to connect the web server and the application together Whereas for the gateway aspect of it, it will act as a bridge between the server and the framework. Whereas for the interface, it defines a standard way for a web application and server communication to be done. It is very important if you want to enable WebSockets for real-time communication, and because we are doing something with WebSockets, that's why we need it. And when you're working with Django channels or even fast API, you can use it to handle connection between your server and the framework. So let's go ahead and establish the ASGI application in our settings.py. Okay, so ASGI underscore application will return this backend.asgi.application. The next thing I'm going to add is the WebSocket routing. Let's call it WebSocket routing, right? For this WebSocket routing, we are using channels, and if you want to understand more about Django channels, I'm going to add the link to that for you guys to read more on the documentation. So for the Django channels, you can go ahead and read more about it, how it works. Channels is a project that takes Django and extends its ability beyond HTTP to handle WebSockets, chat protocols, Internet of Things protocols, and more. So it is built on Python specification called ASGI, like I explained. So we'll go ahead, read this documentation. I'm going to add the link for this documentation for you guys so you can understand more about the Django channel. So let's come back to set up our channels layer. I'm going to do channel underscore layers equals to curly bracket, and we'll return this default where we'll have the backend to be channels.layers. But what I'm going to use, instead of using this in-memory channel layer, I'm going to use the Redis layer, so we can use our Redis server, right? Channels, no, let's do underscore Redis dot. If you don't want to use the Linux server to test run what you're building, you can actually use that in-memory layer just to run your application locally the way you run it with the Python manage.py run server. With the in-memory, you don't need to establish connection to YSL Linux server, but because I prefer doing it with the Linux, that's what I'm showing you guys here. The next one I'm going to add is for the config. Yeah, you can use localhost here, then 6379, which is fine. This can work. Let me just use 127.0.0 then .1, just like this. So this is our Redis server, the default Redis server that we have started. This is the endpoint for it. So that's what we are going to connect. What we are trying to do is to merge this with our local server and help us to create a WebSocket connection between both servers. Then we can start doing real-time communication with it. Okay, that's the only thing we need here. Cross-check to make sure there's no error. There's no error. The settings.py is done. So inside this our app that we have created here, socket app, I'll create a file and call it routing.py. Create another file and call it consumers.py. For the consumers.py, this is where we are going to do all our connection establishing. So I'm going to create a class that's going to help us to connect to our server and accept our WebSocket messages and whatever that happens in our WebSocket. With this, we'll be able to do it, and we are going to be doing it asynchronously. So with the help of ASGI, we don't need to do much because Django has already done a whole lot for us behind the bars that we are not even seeing. So the first thing I'm going to do here is to import JSON, right? Then I will import, let's do from channels generic .websocket. We will import the asynchronous WebSocket consumer. The class, we can call it chat consumer, and we'll use the asynchronous WebSocket consumer. First, we'll handle the one for our connecting. We'll use async. So whenever you're writing async code, which has a function in it, you always start it with async. So this is our function here. That's what we are doing. It is an async function. For this, we will return await self.accept, but I'm going to make this simpler, showing me lots of things I don't want to see right. This is just a simple tutorial to show you guys how to establish a connection to your WebSocket. The real-time chat application I built has more advanced stuff of how this works. Okay, so we'll do json.dumps, and here I will add curly brackets, have message. For the message, we'll do connected to web. Okay, so when we have a connection, it's going to show us in our console that there's a connection. Right now, I'm going to handle the next one for our disconnecting. So for the disconnect, we use self close underscore code. I will just return disconnecting from WebSocket. So let's add bracket for this. Now the next thing is the one that's going to help us to receive information from our WebSocket. Async def receive, then data json.load, then test underscore data will have await send. Here we'll have test underscore data json.dumps, then message. What I'm going to do is, let me return a formatted message here. Return formatted. I'm going to do consumer has been received, so that inside the tool then have append data, the data we added up. So we can leave it like this, but instead of this message that I'm setting here, let me just add the print so that we can be seeing the message of what is going on in our print from the terminal. Let me call it received data. But all these things should be inside the curly bracket, because it is a formatted string. Should be inside the, put it as a bracket space, close the bracket properly. Okay, so this can suffice to just show us how we are creating a connection. So we can go ahead and save this. Now in our routing.py, what I'm going to do is to do Django, from Django.urls, we'll import repat, re_path. Then from our socket app.consumers, right, we will import the consumer that we just created. Once we import that, we'll go ahead and set up our WebSocket URLs patterns where we'll have this, but I don't need this room name because that's not what I'm doing at this moment. Let's remove this. Can work. Then ws/ close it up, comma, then asgi. Okay, now we can save this and come back to the root folder of our backend. Inside this our asgi.py, there are some things we'll have to do. Okay, let me just leave that. We'll import this OS, which is there already. Then this django.core.asgi import get asgi application can suffice. Another thing is to import from channels.routing. We'll have to bring our routing. We will import the protocol type router, and we'll also import the URL router. Next, we will import our routing from socket app.routing. Okay, with this setup, we can leave what we have here. But inside this application, I'm going to change the way we are handling this. So instead of using get asgi underscore application, I'm going to use the protocol type router, and inside it will then have, but first what I want to have, I don't just want to have just this. Above it will have the one for http colon the get asgi application. Then we'll have this one for our socket app.routing.websocket underscore URLs pattern. Okay, so we can go ahead, save this. I think that's all we need to actually test run what we've done. Now to run our server, I'm going to do that thing. If you can establish a connection now, that means the server is working. 0.0.0. You have to do this into 4. Another 0, then you do dash. Our usual local development server is usually 8000. Then you will use the backend.asgi colon application. This is how you run your server. Let's see. Okay, invalid syntax. Let's go back to our asgi. Okay, it's because I did not put comma here. There should be a comma there. That's why it's making it seem like it does not recognize the HTTP. Clear. Let's run the server again. Good. You see, we have this. We are starting our server at TCP. You remember when I told you guys sockets make use of TCP? Now, the server we are using is port 8000, which has the interface of 0.0.0, and HTTP2 blah 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 is not enabled. Now we are configuring the endpoint, and we are listening on this TCP address, which is working with this our WebSocket, with this our ready server that we have already started. Okay, so if you want to now test run what we can come back, try to run our server now and open. Okay, so our Django is working. We can inspect. Let me bring this out. Now to actually see if we have a WebSocket connection, you can come to your network under this place where you see WS, set it on invert. Right now, because I have not done anything, I have not shown a connection yet, but with this invert, once we have a connection, we'll see it. But we can try to run some code on our console.log here to see. So Now if I paste this, what this code is doing for us is establishing a connection, but what we have in our own is chat, not consumers. With this one, localhost /8000/ws, then chat. This is what we have, our code here in our routing. That's what we have. Close down this. No, let me leave the server open because I'm going to use it to show you guys when we have established a connection. So what we have here is the chat, and this is the route, our WS. Now if we go back, since we have this code, let's see if it is working. We can go ahead and run. Good. It says connected, message from server, connected to WebSocket, message from server, message consumer has been received. Order, hello, this is the test. Now if we come back to our network here, I was expecting it to show me, so you can see the WebSocket connections here, right? Let me take it back. So if I open this, you will see that we have some connections, right? It's showing me switching protocols, and if I want to see the raw data, it's showing me the server we are using is Daphne, and we have WebSocket upgrade. If it is not connected, it will not be showing me this green that you're seeing here. Now if you also look at the headers itself, it is showing me the same Daphne server here, and it is returning all. Now let's look at the request headers. You see our local server is 8000 and the origin is this. There's no catch, right? And here is the request URL that is returning this chat that we are seeing. If you come to messages, you will see the message here. You see the message I sent, connected to WebSockets. Okay, now if I try to send another message, we can use sockets, socket.send, and inside it I will do JSON stringify and curly bracket order. I can say this one is another message, close the curly bracket, close this. Now we can try to see if this message will be sent, but let me copy it so we can use it to be sending more message. Another message sent. If we come to our network, I'm expecting it to show me more messages. Okay, yeah, that was the initial one we did, but this one is the one that has all the messages. You can see it has all the messages. Consumer has been received, another test message. If we come back, let me paste and I will say hello WebSocket, and we send. The message will also be received, hello WebSocket. Now if we come back to our code, you can see all the message we are sending. Because I put this print that is receiving the test, it is showing us all the message. Okay guys, so this is how to establish a connection with WebSocket. Like I said, so I built a real life chat system where you can interact with users, and I also implemented authentication in that particular system. So go and watch that video. It is going to give you more ideas and also open your understanding on WebSocket. If you have any questions, you can ask me. I think I have done justice to how WebSocket connection is established in Django. And I have also shown you guys a practical example of how you can test it with your console.log to see if there's a connection established. So guys, thank you for sticking around to the end of the video. Until we meet again, it's bye-bye for now. Please guys, subscribe, like the video, if possible share it, and if you have any questions you can ask me. Till we meet again, peace out. I remain your humble servant, Joshi Vibe.